We're going to look at the somatosensory system in this video. The somatosensory system includes two parts. There's the somatic sensations, which include sensations coming from the body surface. So this would be things like touch, pain, and then also temperature, so feeling things that are hot and cold. And then the other part would be proprioception. Proprioception is giving you information about your body position. So what position are your limbs in? So the somatosensory receptors include the proprioceptors. And remember, the proprioceptors are going to detect the body position or limb position. And a good example of a proprioceptor that we're going to talk more about later are the muscle spindles. So we'll get to that in chapter 12. And the muscle spindles will tell the brain about the length of the muscles. So are they contracted? Are they stretched, relaxed? What are they doing? And that'll help tell the brain about the position of the limb. Another type of somatosensory receptor we have are mechanoreceptors, so they're really important for touch. And then we have thermoreceptors, which obviously are going to detect skin temperature. So are you touching something hot, something cold? And then remember, nociceptors are going to be detecting pain. So that would be important to remember. Let's take a look at the sensory receptors in the skin. We have two different types. Some of the sensory receptors in the skin are encapsulated nerve endings, and then others are going to be free nerve endings, so there's no capsule around the dendrites. And the type of stimuli that sensory neurons with free nerve endings are going to be detecting, some of them are going to be detecting pain, and then others will detect temperature, and then some will be detecting some of the types of touch. And then the ones that are encapsulated just detect touch. This is a picture of the mechanoreceptors in your skin. You don't need to memorize these. These are just kind of interesting to look at. So for example, you've got the hair follicle receptor. You've got a sensory neuron wrapped around the hair follicles. So when the hair on your arm gets brushed, you can actually feel that. So that's kind of interesting. But there's all kinds of different sensory nerve endings here that pick up some different stimuli, and they're just very interesting to learn about, but unfortunately we don't have time to learn about all of these, but they're interesting to read about. All right, let's move on to the thermoreceptors in the skin. So these are all free nerve endings, and they're going to be detecting changes in the skin temperature. So some of these will detect warm temperatures, and then others will detect cold temperatures. So we've got a little graph down here on the bottom that shows the temperatures that the cold receptors will react to, and then the temperatures that the warm receptors will react to. So for example, if you've got an ice cube that you've put on the skin and you cool the skin temperature down, you can see that the warm receptors in that area of the skin will not react to that, but the cold receptors will start reacting to that and generate some receptor potentials and then be sending some action potentials to the cerebral cortex, letting you know that, hey, that area of the skin is cold because you've got an ice cube on there. And then when the ice cube gets taken off, then the cold receptors stop responding, And then the warm receptors will actually respond because now the skin temperature has changed and it's now warmed up. And so now that area will feel warmer. And another thing that's just interesting to point out, I don't know if anyone has ever been burned before, but sometimes when you get burned, instead of it feeling really hot, it actually starts to feel really cold. And the reason that is that when the skin temperature gets really hot, when you're getting burned, that actually activates the cold receptors. And so you actually feel cold instead of hot. So they call that paradoxical cold because even though you're getting burned by something really hot, your skin actually feels cold. So that's kind of odd. I don't know why that is, but that's just the way it is. Okay, so let's just take a look at how these thermoreceptors work. So let's take a look at the cold receptors on the left. So these are just some gated ion channels, and what's going to be opening the gate would be a change in the temperature. So maybe the skin, got an ice cube put on that would open the gate. And here we've got sodium and calcium ions coming into the sensory neuron ending there, and that would create a depolarizing receptor potential, which would be excitatory, and maybe we'll reach threshold and create some action potentials and then send that signal up to the brain, telling you that, hey, skin temperature's changed and you've got an ice cube on your arm. The other thing that can actually open up the cold receptors would be mint. So mint can actually bind to the cold receptors, and that's why when you eat mint, your mouth feels cool. So your mouth did not change temperature at all, but the mint will bind to those cool receptors and actually open them and give you that cold sensation in your mouth, which is kind of interesting. Okay, and then we also have the warm receptors, which again are these gated ion channels, and when the temperature warms up on your skin or in your mouth, that'll open the gate and sodium and calcium ions will come in, cause a depolarizing receptor potential, and then we can reach thresholds and some action potentials up to the brain, and then that will give you that hot sensation. So the other thing that will open up these warm receptors is capsaicin, which comes from hot peppers. So if you eat some spicy food with capsaicin in it, it will bind to those warm receptors in your mouth, open up those warm receptors, and you will get a warm feeling in your mouth, even though your mouth did not change temperature. So that's kind of interesting. The nociceptors in the skin, they're going to detect pain. They have free nerve endings, and the axons of these sensory neurons are going to be either A delta or C fibers. And we'll take a look at that in just a minute. And there's different types of nociceptors. So we do have mechanical nociceptors. They're going to detect mechanical stimuli. So for example, if you stub your toe or you drop a rock on your foot, they would pick up that mechanical stimuli and give you pain from that. Thermal nociceptors are going to detect extreme heat or extreme cold. That would be damaging to the tissue and give you pain from that. And then these polymodal nociceptors, poly meaning many, so they're going to detect mechanical stimuli, extreme heat or extreme cold, and then also chemicals from inflammation. They can also give you pain from that. So these polymodal nociceptors respond to lots of different stimuli to give you pain. All right, so let's take a look at the nerve fiber types. We've mentioned this before, but we're going to be talking about this a little bit later, these A delta fibers. they do have a myelin sheath, and they do have a wider diameter than the C fibers. The C fibers do not have a myelin sheath, and they have a smaller diameter. So as far as transmission speed, the A delta fibers are going to transmit the pain signals faster than the C fibers do. So we end up with the A delta fibers will transmit what's called fast pain, and then the C fibers are going to transmit what's called slow pain. And then we'll talk about that in the next video. Okay, and then these are just a summary of the sensory receptors in the skin, so you can just kind of look through that. And then the two somatosensory pathways. I'm not going to ask you the names of these pathways, so you don't have to memorize those. But I just want you to realize that the central nervous system is very organized. And so everything has its place. So we're going to be transmitting touch and proprioception. That's going to go up one pathway to the cerebral cortex, and then pain and temperature is going to go up another pathway. And we're going to have both pathways crossing or decussating. Okay, so let's just take a look at these pathways. So the first pathway is called the dorsal column medial lemniscal pathway. I will not ask you that name. You do not have to memorize that. But this pathway is going to be transmitting information about touch and proprioception. And notice that we've got 3 sensory neurons to get that information up to the primary somatosensory cortex in the brain. So we've got on our periphery, we've got our first order neuron that's going to pick up the touch stimulus or proprioception. Maybe we've got a muscle spindle here on the muscle. Here's our first order neuron, and we'll travel up, go up through the dorsal side of the spinal cord, and then we're going to travel up through the dorsal column, the white matter of the spinal cord, because we've got these myelinated axons. Go up to the brainstem here, synapse with our second order neuron, and then notice how we're going to decussate or cross over. And so whatever touch or proprioception is coming from the left side of the body is going to end up on the right side of the brain. And then here's our second order neuron. We're going to synapse in the thalamus. Remember, that's our big filter for sensory information, and the thalamus will decide if that information is important enough to send on. And if it is, we'll synapse here with our third order neuron, and then that will take the information to the primary somatosensory cortex, and then we'll become aware of that touch or proprioception information. Pain and temperature is going to be traveling up a different pathway called the spinothalamic tract. You do not have to know this name either. Notice that we're going to be taking 3 sensory neurons to get from the periphery up to the cerebral cortex. So we're going to be taking our pain or temperature stimulus, and we're going to be starting out here in the periphery with our first order neuron. We're going to travel up here, enter in the dorsal side of the spinal cord. We're going to synapse with the second order neuron. And then notice we're going to decussate or cross over. So pain or temperature coming from like the left side of the body is going to end up on the right side of the brain. And then we'll travel up through some white matter up through the spinal cord, up through the brainstem. We're going to synapse in the thalamus. Thalamus is our filter again. It'll decide whether that information is important enough to send it on up to the cerebral cortex. If it is, we'll synapse with the third order neuron, and then that will take the information to the primary somatosensory cortex, and then you'll be aware of that pain or temperature stimulus. Okay, and then the primary somatosensory cortex. So that is pictured here in blue. And remember that that is located in the parietal lobe. So hopefully you got that right. So all of this information about touch and skin temperature, pain, proprioception, all of that information is going to end up in this primary somatosensory cortex in the parietal lobe. And remember that each part of the body has its own area that's devoted to it in the primary somatosensory cortex. And we end up with this representation of the body here, this sensory homunculus or little man. And we don't have equal representation of the body parts because some areas of the body have more sensory neurons than others, like the lips are very sensitive. So hands are very sensitive. We have a lot of sensory neurons there. And so this is what your brain thinks your body looks like. So thank goodness we don't actually look like that.